Again, welcome to Java programming language. In these lectures, we're going to continue with the selection statement. In our previous lectures, we discussed about the relational operators and also how to form or create a conditions in Java language. So this will be a continuation, and in these lectures, we're going to cover the logical operators. Logical operators make it possible for us to combine two or more conditions together. Again, our previous lectures, we have only one condition at a time using the relational operators. Here, we are going to use both the relational operators and logical operators to combine two or more conditions. We're also going to discuss about the syntax for switch statements. Switch statement is also a selection statement in Java. Instead of using the multiple if-else statement, we can also use the switch statement. So let's start with the logical operators. In Java, we have four types of logical operators: the NOT operator, AND operator, OR operator, and exclusive OR. They are also called the logical negation, logical conjunction, logical disjunction, and logical exclusion. We are not going to use this term in Java language. Normally, these terms are used in discrete mathematics. So we start with the NOT operators. For example, if we have a condition for P, we assume P is a condition, and we say not P, it means if P is true, not P will be false. If P is false, not P will be true. So we normally say the NOT operator is a unary operator. It takes only one condition at a time. So let's see this example. We have age. We are assuming age is 24, weight is 140. Now, if we have a condition saying that not age greater than 18, the answer will be false because age greater than 18 is true. So not age greater than 18 will be false. The second example, weight is equal to 150. Our condition is supposed to be weight equal to 140. So if weight is equal to 150, that's false, and not false will be true because weight equal to 150 is false. So not false is true. Next is the AND operator. So the AND operator also is called the binary operator. It should have two or more conditions. Here we are going to use only two conditions to do some example. So let's assume we have two conditions, P1 and P2. Now, if P1 is false and P2 is false, then the outcome of P1 and P2 will be false. Now, if P1 is false, but P2 is true, the outcome of P1 and P2 also will be false. When P1 is false, and when P1 is true and P2 is false, the outcome also will be false. We only get true condition outcome if all the conditions are true. So when P1 is true, P2 is true, then our outcome will be true. So we only get, with the AND operator, we only get true if all the conditions are true. Again, we use the AND condition, the AND operator to combine two or more conditions. So I may have four conditions. If all the four conditions are true, then the outcome is true for AND operator. But if three of them are true and one is false, the outcome is still false. So let's see the example here. Again, here we are assuming age is 24. Also, the weight is 140. So we said if age is less than or equal to 18 and weight is less than 140, the answer is false because at least one of them are false, if not both of them. In this case, both of them are false because age is 24, less than or equal to 18 is false. Weight is 140, less than 140 is also false. The next example, we say age is greater than 18, which is true. And weight is greater than 140, that's false because weight is 140, not greater than 140. So the outcome will be false. Why? Because weight greater than 140 is false. Now, if we have age greater than 18 is true, and weight greater than 140 is true. So the condition here will give us true. Why is it true? Because both age greater than 18 and weight greater than or equal to 140 are true. So the outcome will be true. Let's try the next one, which is the OR operator. So here we still have two conditions, P1 and P2. Now with the OR, we only get false when both conditions are false. Then the rest are true. So even, for example, if we have 5 conditions and 4 is false and 1 is true, the outcome is still true. So here we can see P1 is false, P2 is false, the output is false. But when P1 is false and P2 is true, the output is true. And also when P1 is true and P2 is false, the output is still true. And when all of them are true, the output is still true. So let's see this example. Age is greater than 34 or weight is less than 140. This is true because weight less than or equal to 140 is true. Now, age greater than 14, that's true because age is 24. Or weight is greater than or equal to 150 is false. But since age greater than 14 is true, the output will be true. Now let's go to our last one, which we call the exclusive OR operator. Now with the exclusive OR operator, also it's a binary operator. We have two conditions here, P1, P2. Again, the condition can be more than 2. Here, if the P1 and P2, if the conditions, all the conditions have the same outcome, then the output is false. What I mean by that is that, for example, we have P1, P2, P3, P4. And all the P1, P2, P3, P4, all of them are true or all of them are false, then the outcome will be false. If one of them is true and at least one of them is false, then the outcome is true. So here we are using P1 and P2. False, false, give us false. True, true also give us false. But true, false or false, true give us truths. So let's see the example here. Age is greater than 34, exclusive OR. Weight is greater than 140 is false. Why is it false? Because both conditions are false. Age is 24, it's not greater than 34. Age is 140, not greater than 140. So all of them are false. The next one, we have age greater than 34, which is false. Weight greater than or equal to 140 is true. So the outcome will be true since age greater than 34 is false and 1 is true, then the answer will be true. Here also we say age greater than 14, which is true. Exclusive or weight greater than 140, that's false. But because again, 1 is true, 1 is false, the output is true. So now let's see an example by showing again the logical operators. Here we have a program that will check whether a number is divisible by 2 and 3. Then the next example, whether a number is divisible by 2 or 3. And then whether the number is divisible by 2 or 3. So again, we are going to start with the first one. Here means we are checking the condition whether the number we enter is divisible by 2 and 3. So the condition will be number modulus 2 equal to 0. We know modulus 2 means if I divide any number by 2, if the remainder is 0, then it's divisible by the number 2. So anytime we use modulus operator means if I divide a number by 2, the remainder is the answer. So if the remainder is 0, that means the number is divisible by 2. And the same number also, we want to check if it's divisible by 3. So we divide the number by 2. If the remainder is 0, then it's divisible by 3. Now, if we want to check whether the number is divisible by 2 or 3, then we use the OR operator. So one of them have to be true or both. The next one, we check if the number is divisible by 2 or 3 again. This is another option. Instead of using the OR operator, we are using the exclusive OR. You remember exclusive OR said, if both conditions are true or both conditions are false, the answer will be false. But if one of them is true and one of them is false, the answer again is true. So I can, OR means I want to know if the number is divisible by 2 or 3. So I use this, but we have to be careful with this. Remember, if the number I enter is divisible by 2 and also divisible by 3, then I'll get false. But with OR operator, if it's divisible by 2 and also divisible by 3, I will still get true. Because with the OR operator, if everything is true, it still get true. But with exclusive OR, if one of them is true and one is false, you get true. But if all of them are true or all of them are false, you get false. So we have to be careful when we are using exclusive OR. So the AND and also the OR operators, here we say that if S is 1, what is X after this expression? We are given S is greater than 1 and S plus plus less than 10. So if X is greater, remember here we are using the N. So our result here means both conditions have to be true. Now the next one, if S is 1, what is X after this expression also? Again, both conditions have to be true. Is 1 greater than 1? No. So this will give us false. If one condition is false, then everything is false. Same thing applies to the first one. How about 1 equal to X and then 10 is greater than S plus 1? So here in this case, only one condition have to be true. Or both conditions have to be true, then we get a true output. Now let's see this program, again, using the logical operators. We want to go through a program that will prompt a user to enter a year. Then we are going to check if the year is a leap year. We know in actual world, we get leap year every 4 years. A leap year means the February, instead of 28 days, it will be 29. So leap year increased by 1 day. But this happens every 4 years. So again, this program will first prompt the user to enter a year as an int value, and it will check if it is a leap year. So we know that a year is a leap year if it is divisible by 4 every 4 years. But we have to be careful and not by 100, because we know every 4 years. So when we reach 100, there will be some problem, either 98 to 102. So what we're trying to say is that we know 4 will be divisible by 100. 4 times 25 is 100. So our condition will be the year modulus 4 is equal to 0, which is fine. The year should be divisible by 4, but the year shouldn't be divisible by 100, but it should be divisible by 400. So that's the condition. The reason why, because every 4 years we have a leap year. So whatever year we enter, modulus 4 equal to 0, but not divisible by 100, but by 400. So this is the code here. Again, we have our main class named LeapYear. We are using the scanner class to get the input. So we create our scanner object, we name it input, and we ask the user to enter the year. So we use the scanner input object dot nestInt. We are using nestInt method because our input is integer and we declare variable name year. The type also is int. So the user enter the year, it will go to the variable year. Then now we have our condition, check if the year is a leap year. So we are using a variable is leap year boolean, true or false. So the condition is if the year modulus 4 equal to 0, and so both conditions have to be true, and the year modulus 100 not equal to 0, or the year modulus 400 equal to 0, which means if the year modulus 4 equal to 0 and the year modulus 100 is not equal to 0 or is equal to 0, then this will be false. But if the year modulus 400 equal to 0, then the outcome will be true because this is OR operator. Either the left side is true or the right side is true. So if left side is false and the right side is true, we say, because the year modulus 400 always will give you the leap year. But modulus, if we use modulus 4, we have to check and make sure that it's not divisible by 100. So then we display our result. So our result here will be display either the Boolean variable is true or false. So the last section will be the switch statement. Switch statement, as we said, is almost same as multiple if-else statements. So for example, the syntax, we use the keyword switch. The status will be what we are testing. Say, for example, I will say switch grade. If my grade is 0, then compute taxes for single fileless. If it's 0, so the cases here, again, the syntax, we use the keyword cases. The case, what comes after the case here, we have 0, which means the status here, the answer is 0. If the status answer is 0, then it's going to compute taxes for single fileless, or whatever statement we have is going to execute, then we break. If the first case is not true, we go to case 1. If case 1 is not true, we go to case 2. If case 2 is true, then we are going to compute taxes for married file separately. Then we break, then we come out. Anytime we break, we will come out of the switch statement. So only one statement will execute. Now, if all the cases are false, then the last option, the default, again, this is a keyword default. The last option always print. If none of the case printed, then the last default section will print. Or in this case, whatever execution we are doing. So that's the syntax. We always have the switch case and the variable name, or it can be any name you have, the condition you want to check. Then the case, what answer it should be, the variable should be 0, 1, 2, 3. It can be as many as we want. So this is the idea. We have the switch statement. If the status is 0, then we are going to compute the task for single fileless. Then we break. Then we continue, we come out of the switch statement, continue with the program. Now, if case 0 is false, then we go to case 1. If it's true, we compute and come out of the switch statement. So again, that's an example here given to us. So for example, we have a switch. The switch expression always will be here. And the case, if the switch expression value is 1, then the statement will execute, then break. If the value is n, value n, then it will execute the statements in n. If none of them, then the last statement will execute. So here we say the switch expression must yield the value of character, char, short, or int. So for example, it's not good to use a grade. For example, if we have a test score, we say that, okay, if you score between 90 to 100, your grade is A. It's better to use the if else, because in the switch statement here, the switch expression here, we can't enter an interval value. It have to be one specific value. Otherwise, we can say, okay, switch case 90, 91, 92, 93, which is not good. To be too much statement. So when you are using the switch statement, one of the first rules is that the switch expression, the value shouldn't be an interval value. It should not. It should be either 90, 100, A, B. It should be only one single value. Then these are all the possible cases that can be executed. So if it's value 1, value 2, value n, it shouldn't be an interval. It should be one specific value. So we always use the keyword break to stop the loop, as we said. And so whatever execution, whatever condition is true, when we execute, we break. Break will take us from the switch statement. So here we say when the value in the case statement matches the value of switch expression, the statements starting from this case are executed until either the break statement or the end of the switch statement is reached. So statement 1 execute, we see break, then we come out of the switch statement. So this is an example, a trace switch statement. You can see that our variable is a day, very good one. A day can be only 1, 2, 3. It cannot be between 2 to 10 or 1 to 5. Again, with a switch statement, we use a particular value. We don't use an interval. So here we say, okay, suppose the day is 2. Then case 2 is the 1. Then case 2 is going to case 3, 4 through case 3, and 4, 5, and then we break. Why? Because this is where we put the break. So you can see that case 1 didn't do anything. We went straight to case 2. So it's very important where you put your break. Again, you can put the break at anywhere. Let's say I can put the break case 1 break, case 2 break. Now, if we put case 2 break, then whatever happened in case 2, after it break, it will not check case 3, 4 no more. It will come out of the switch statement. So here we put a break here, which means if the case is 2, 3, 4, 5 will still go through. Then we exit. So anytime we see the break, we exit from the switch statement. So let's see our last example, which is a Chinese Zodiac program. This program will ask a user to enter a year. Then when the user enter here, it's going to be displayed the animal for the year, which normally the Chinese Zodiac. So for example, if user enters 0, it will be monkey, 1 is rooster, 2 is dog, 3 is pig, 4 is rat, 5 horse, etc. Now you can see that here we have a specific value for each animal and the value. So we can either use switch statement or we can use the if else. Now if else, we can use it for a particular value. We can also use it for interval values. But with the switch, we can only use one specific value. So let's see if we can see this program. I think we have the program here. So here again, we have our main class, Chinese Zodiac. We have our main method. When the user enter the year, you can see here we are using a switch statement. We say the year modulus 12. Because we go from 0 to 11, we can't go more than 12. 0 to 11 is 12. That's why we have modulus 12. Now, we can see that each case, we have a break. So if user enter any value, let's say 4, 5, any value, then it's going to give the. Now, if user enter 13, you can see there's no 13 here. So what will happen is that 13 modulus 12 will give us what? 1. So the answer will be 1. Now, if user enter 12, we don't have no 12 here. So 12 modulus 12 will give us 0. So we start from 0. So any value the user enter is going to give us from 0 to 11, 12. So that's why we are using the modulus operator. But you can see that the answer is still one particular value, not interval values. So for example, if I enter, let's say 90, even if I enter 100, we can still have 100 modulus 12. I think 12 will give somewhere around like 96, so it will be somewhere around 4. I'm not 100%, but when you divide a value by 12, the remainder of that value should be between 0 to 11. It shouldn't, because if the remainder is 13, that means 12 can go into 30 one more time, then remainder will be 1. So no matter what the value here is, it can be 2,000, 3,000 modulus 12, the remainder always should be from 0 to 11. So this will be the conclusion of our lectures. Again, in these lectures, we focus on going through the logical operators. As we can see from our last program example, we saw how we can use the switch statement also. Here we see the way we implement our switch statement. And those are the two major things we study here. So again, if you have any question, feel free to ask at work, at school, or you can send an email if you have any question. Thank you for your time.